restricting a function so that its inverse can also be a function. Particularly, we're talking about a parabola. We have two lines, vertical line tests, which is used to test if the graph is a function or not. The graph, in order for the graph to be a function, it should be a one-to-one, meaning that for every one x value, there should be one y value. A one-to-many is not a function. One x value to many y values is not a function. Number two, the horizontal line test is used to test if the inverse, listen to me carefully, is used to test if the inverse of that function will be a function, if the inverse will also be a function. A many to one is a function, but its inverse becomes a one to many, which is not a function. Remember, we talk about a one to many here. So let's get talk about this more in details. Let me draw a couple of lines. This line crosses here. I just don't want to mess everything up, but it crosses the intersects the graph. I'm drawing two lines here. Okay. These two vertical broken lines are the vertical lines used to test if the function is a graph or not. As you can see, in order for the function to pass as a graph, it should be a one-to-one, meaning that the vertical line should only touch the graph once and pass, only once and pass. Then the horizontal line, which is this one, these two lines I'm using here, if the horizontal line touches the graph twice, horizontal line once and twice, it is still a function because that's a many to one. But its inverse, let's draw the line y is equal to x, which is a line something like this. Sorry, that's not accurate, but okay. Okay, this is the mirror. Let's take this is the mirror, and you're standing right here. Then your reflection will be something like you will shift the values. Since -3 here, which was the y-axis, will be the x-axis for that for the reflection of that function. So it will be something like this. This is the -3 here, and the turning point will do the same thing as the y-axis turning into x-axis. The turning point, which was x was 1 and y was -2. When you come to the inverse, which is f -1, which is the inverse, okay, the -2 will be the x. The +1, which was x this side, will be the y. Sorry, made a mistake again. But here, this is 1, and the x is 2. The y is 1. The y is 1. The x is -2. Okay, so its inverse. This is the inverse of the function f. Ne? The function was a many to one when you're using the horizontal line test, and when you're using the vertical line test, it was a one to one. It was only touching the graph only once. But now let's take it. Let's take the vertical line test and use it to test this graph. As you can see, this is not a function. It's the inverse of the parabola, which was a many to one. It was a many to one, which was a function, but a one to many is not a function. So if you take a look at the horizontal line, which is to test if a graph is a function, you can see that the line is touching the graph twice. Let's take a look at this line. It's touching the graph right here, and also again at this point. So this is not a function. All right, now let's get into restriction. Basically, by restriction, we're trying to cut the original graph at the middle so that its inverse can also be a function, a one-to-one, when you're using the vertical line test. So I want you to notice something. I already drew a line here, the line of symmetry, cutting the graph, leaving the graph with two equal parts, which is this part, this side, and this part. Notice that if I erase this part, and only leave this part. The reflection of this part is this part, right? So if I erase this part, that means from the inverse, this part won't be there, meaning I'll only be left with this part. And if you draw the vertical line, the graph will only be touched once. I hope that's clear. The graph will only be touched once. And what's the value of x at this turning point here? The value of x at exactly the turning point is equal to 1, right? So it means that if I want to take only this part and exclude this other part so that the inverse can be a function, if I want to include only this part, I will say x is greater or equal to 1. Notice I took the 1 from the turning point, yeah? And it's also here in this equation. The 1 is from the turning point, the x value of the turning point. Yeah? So if x is greater or equal to 1, I will only be taking this part. By x is greater or equal to 1, we're talking about this part from right here, because this is 1, right? And this part, this can be this is 1, this is 2, let me say this is 3. I'm just writing these numbers to give you an image of what I'm talking about. All these numbers from this side, which is this part. So basically, I'm talking about this part, and from the x values, the from the x axis, the values are increasing 1, 2, 3, 4, 5. So you are including all those values, and you are uh, using x to represent all those values. Yeah? You are representing all these values using x. So when x is greater than 1, which all the values that are greater than 1, you are only left with this part. You are only left with this part. And for the equal part, you are also including that middle where you cut the function. So basically, you're just taking this part. Let me draw it right here. You're just taking this part and reflecting it to this side. So this is what you're only going to be left with. This will be the f, and this will be the inverse of f, right? Now, if you take the vertical line, notice something. The line only cuts the graph only once. This is what you're trying to achieve all along. The line only cuts the graph only once this time. This is what you're trying to achieve. So what was the restriction? The restriction was x is greater or equal to 1. So, but it doesn't mean you have to always take this part only. You can also take this other part. And when you're talking about this other part and one this is 1 here, you meaning that you're going to talk about values, all the values that are less than 1, because as you can see from this line, 3, 2, 1 can be 0 0.9, 0 0.5, all the numbers that are less than 1. So if you want to take this part only and erase this part, and you want to take only this part, which will only reflect this part only, it means you're going to take x is less or equal to 1. I hope that's clear. I hope that's clear. So now what are you going to have from this? You're going to have this part and its reflection, this part. That's the inverse. And from the vertical line, it will only be touched once. You will only cut that line, that function once. And it becomes a one-to-one, which is what you're trying to achieve all along. So I hope that's clear. So, okay, so the equation for the inverse, let's first switch the values. Instead of y is equal to, now is x is equal to y minus 1 squared. So now I'm trying to make y the subject. So let me take this uh, whole, whole thing and take it to the other side. It will be positive. Now it will be y minus 1 x squared is equal to negative x minus 2. right? What else? Going to take the square root of this side and the square root of this side. Let me erase this quickly. What will I be left with? Y minus 1 is equal to plus or minus the square root of negative x negative 2. Y is equal to plus or minus the square root of negative x negative 2 plus 1. Yeah. So I want you to note something. From this, the inverse, you will notice that when there's plus or minus, you get two lines of the inverse, right? So in order for the restricted part, you only get to choose one from this. It's either you're going to take the positive side, not you're going to not include both positive and negative, plus or minus. For the inverse part, you're going to take it's either you're going to take positive depending on which one you restricted from these two. Depending on which one you restricted from these two. So if I'm going to take the positive part, then you're only going to use the positive part depending on which side you chose. You cannot use a plus or minus if they tell you to write the equation for the inverse, for the restricted inverse. You're only going to take the minus or plus depending on which side you chose from these two. Because one side from this positive and negative forms this side, and the other side forms the other part. Yeah, so that's it. I hope that's clear.